So, in my last video I have explained the method of undetermined coefficients to find the general solution of a second order linear non-homogeneous equation. This is the method called annihilation method. So, right side you annihilate by operating some differential operator, and then what you get to end up is the higher order equation with constant coefficients. Okay. So, and then for which you take the general solution and you remove the general solution of the given equation, given homogeneous equation, whatever the solution you will get, those terms from this general solution of the higher order equation you remove it, remaining whatever is remaining, then whatever is remained is the form for which you should look for as a particular solution. This you substitute into your non-homogeneous equation to find these constants. This is the method we followed. Let us do some problems. Okay. Let us do this one more problem on this example. So, let us solve the non-homogeneous equation y double dash plus 2y dash plus y equal to 5 plus x square into e power x. You see this 5 is a constant, it is a polynomial of 0th degree, and this is a polynomial and combination with exponential. So, I can use the method of undetermined coefficients. Okay. Just to explain the method, it may take long calculations may take long time. Okay. So, the given equation is this. So, you can rewrite. So, let us write d dx as d. If you represent this as a d, I can write d square as d square by dx square. Okay. So, d square plus 2d plus 1, this acting on y equal to 5 plus x square e power x. Okay. So, x is in full R. So, nothing is given means it is in full real line. So, I want to annihilate 5 plus x square e power x. If I differentiate with d dx, then I can remove this 5. Okay. And this alone will not help. Okay. And I can explain x square, I can annihilate x square e power x. E power x, if you want, you have to divide with d plus 1 acting on e power x equal to 0, right, or d minus 1. D minus 1 is the operator. If you apply to e power x, that will be 0. And what is this x square e power x? You should have d minus 1 power 3. Okay. Then this is equal to 0. So, if you think of this as z of x is actually having a solution e power x, x into e power x, x square into e power x. So, all three solutions will have. Okay. This is the third order, d minus 3 cube, d minus 1 power cube. Okay. So, if you think of this as a differential equation, so that is what happens. So, if you want to annihilate x square in this, you have to multiply d minus 1 cube. D minus 1 cube, if you apply here, it will not annihilate. So, and because d minus 1 cube and d is here, this is this d, one derivative, this together will annihilate these two things together. Okay. Right, because this is same as d minus 1 cube into d. Okay. This is commutative. So, you can apply. So, the d into d minus 1 is same as d minus 1 into d. Okay. But because these are with constant coefficients, d minus 1 cube is actually the equation with constant coefficients. But if I have some powers, for example, if I have d minus x, then this is not commutative. Okay. D minus x d, this need not be commutative if you actually expand and see. Okay. Because this is commutative with constant coefficients. Okay, this is actually same, that is why you apply this first, that makes 5 0, and on that you are operating on d minus 3 on 0. So, d minus 1 power 3 0 is anyway 0. So, that is how either this or this, both are same, will be annihilating the right hand side. So, you apply both sides. So, d into d minus 1 cube d square plus 2d, d square plus 2d plus 1 is d plus 1 whole square on y equal to 0. Okay. So, what is the solution? what is the solution? So, if we call this auxiliary equation, this is called the auxiliary differential equation, auxiliary equation. Okay. So, if you want to call this y a of x will be, so what are the roots here? You can see that this is, so you simply look for e power lambda x, okay. E power lambda x, if you put it, you have lambda minus 1 power q and lambda plus 1 square equal to 0. So, these are the roots you will get. So, lambda 0, lambda is 1, 1, 1, 1 3 times, lambda is minus 1 minus 1. So, these are the things you will get. So, if you actually, once you know all the roots, you can write the general solution of this. What is the general solution? C1 e power 0x, that is 1, okay, C1 plus C2 e power lambda x, what is 1 x, plus C3 x e power x plus C4 x square e power x. So, these are the 3 solutions corresponding to lambda equal to 1 1 1. Next thing is C5 e power minus x plus C6 x into e power minus x, because minus 1 is repeated twice. So, this is your solution. And what is your given equation? D square plus 2d plus 1y equal to 5 plus x square e power. So, what is the homogeneous equation? Given homogeneous equation is d square plus 2d plus 1y equal to 0, for which if you actually look, follow the same procedure, that will have the roots minus 1 and 1. So, you should remove, this is the general solution of the homogeneous equation, given homogeneous equation. So, this part you remove it. So, this is the form you have to look for, whatever remaining, this is the form you have to look for as a particular solution. So, look for the form C1 particular solution yp of x, okay, is equal to C1 plus C2 e power x plus C3 x e power x plus C4 x square e power x as particular solution, as a particular solution of given a given non-homogeneous equation. Okay. So, we will just substitute into the equation now. So, what you do? You need yp dash, yp double dash. Yp dash is simply C1 goes to 0. So, C2 e power x plus C3 e power x plus C3 x e power x plus 2 C4 x e power x plus C4 x square e power x. Okay. So, this is what is yp dash. Yp double dash is also is equal to C2 e power x plus C3 e power x, C3 e power x it will have a 2. So, C3 x e power x plus this, if you differentiate, you will have a 2 C4 e power x plus 2 C4 x e power x, again here 2 C4 x e power x plus C4 x square e power x. So, C4 x this will become actually 4, this together is actually equal to 4. So, you can rewrite this as 4, I can remove this part. Okay. So, this what is your y dash, y double dash. This you substitute into the equation d square plus 2d. So, d square is y double dash p. So, if this is equal to this one plus 2 times, okay. So, let me write it. So, C2 e power x plus 2 C3 e power x, C3 x e power x plus 2 C4 e power x plus 4 C4 x e power x plus C4 x square e power x. This is your y double dash plus 2 times yp dash, 2 C2 e power x, 2 C3 e power x, 2 C3 x e power x plus 2 C4 x e power x. This 2 becomes 4, okay. And then I have a 2 into this, 2 into 2 4. So, plus 2 C4 x square e power x plus y. So, y is C1 plus C2 e power x plus C3 x e power x plus C4 x square e power x, which is equal to 5 plus x square e power x. That is what is given. So, this is a given non-homogeneous equation, that is why I substituted. Now, just by comparing the coefficient, you can find the solutions. You can calculate this constant C1, C2, C3, C4. So, how do I do? First constant. What is the constant? So, simply constant is C1. C1 is fixed as 5. So, this implies C1 is 5, that is fixed. What is the next coefficient? E power x. E power x coefficient is C2 e power x here. Okay. So, that is C2 plus 2 C4, okay, here plus 2 C2. So, C2 plus C2. So, they have a 3 C2 plus 2 C3 from here. Okay. So, this is what I am doing. This 2 C3, this is 2 C3 is 4 C3. Okay. C2, this C2, this C2, C3 is over. Okay. C4 is C4, 2 C4, and I have C4, I do not have anywhere. So, C4 plus 2 C4 is exponential of x here 0, coefficient is 0. Okay. And I missed this was C2, one more C2, I have together 3, 4. Okay. So, 1, 2, 3, so 4. Okay. Total 4 C2, C2, C4, C3, okay, C2, so if you want you can rewrite. So, this means where is this 2 C4? So, 4 C2, 4 C3, this is 1, 4 C3, okay, 4 C2. So, where is C4? C4 is 2 C4. And then only 2 C4, right. So, only 1, we do not have anything else, only 1 2 C4 is there as an exponential function, right. So, nowhere. So, this is actually equal to 0. So, this is equation 1. Now, make a coefficient of x into e power x, whose coefficient is also 0. Okay. This is by a coefficient of e power x. This is coefficient of x into e power x. So, x into e power x, if you look at it, C3, C3, okay, here 2 C3. So, 3 C3, 4 C3, okay, 4 C3, and then x into e power x, 4 C4 here, okay, 4 C4, 4 C4, 8 C4, 8 C4, just 8 C4, that is all, equal to 0. So, 4 cancel. So, you have, this is what you have, this is equation number 2. Now, we make a coefficient of x square e power x, that is your equation number 3. So, what is your x square e power x? As coefficient is 1. So, I have 1, x square coefficient is C4 here, 3 C4 here, 4 C4, equal to that. So, that will fix C4. So, this implies equation 3 gives me 1 by 4. Once you put it, this gives me 2 gives me C3 as minus 2 times C4 is 1 by 4. So, that is minus half. Once you know C3, C4, you can find C2. C2 equal to minus 2 C4 minus 4 C3 divided by 4. So, this is 1 by 4 times minus 2 times C4 is 1 by 4 minus 4 times C3 is half, that is minus half. So, plus half. So, this is 2, this is 2. So, this you get 1 by 4 times minus half plus 2. So, this is actually equal to 3 by 2, right, 3 by 2, 3 by 8. So, that is your C2. So, having known all C2, C1, C3, C4, you can go and substitute into your YP. This is your solution. Okay. That implies the general solution of the given equation is y of x, which is, what is your homogeneous general solution of the homogeneous equation which you cut off? This one, C5 e power minus x, and C3, C5, C6, they are arbitrary constants. Let me write it as C1, okay, some D1 if you want to call this, okay, or you keep them as it is, C5 e power minus x, C6 x e power minus x. This is the general solution of the homogeneous equation plus the particular form. So, what is the particular form? C1, C1 is 5 plus C2 is 3 by 8 e power x, right, C2 e power x, C3 x into e power x. What is C3? Minus half x into e power x, and C4 x square into e power x. What is C4? 1 by 4, 1 by 4 x square into e power x. So, this is your general solution because it has arbitrary constant C4 and C5 and C6. So, this is the general solution of the given equation. This is how you will find. So, method is pretty simple, only you have to understand how it is done, the procedure, just have to look at the procedure. Okay. So, you look at the algorithm, take the equation, annihilate it with an operator. If your equation is given equation is with variable coefficients, then once you annihilate it with an operator, okay, because you are only annihilating simple functions, your annihilating operator is only derivatives d's with constant coefficients. They are simply constants, okay, d and simply constants. That if you multiply with the equation, actual equation, okay, that is d plus 1 whole square. This d into d minus 1 cube, if you operate your given equation is not like, let us say, d plus 1 whole square. If it is not this, let us say if it is the equation with variable coefficients, something like d plus x whole square, then you cannot, even though you know your homogeneous solution, because this is not same as d minus, so this is not commutative. So, you cannot do this is d plus x whole square into d minus 1 cube. So, you will have a problem. So, that is why this method only works if it is a constant coefficient equations with right hand side simpler elementary functions, combination of these 3 elementary functions. Okay. Just for the sake of giving this method I have given, so you can actually apply this method and get the general solution of non-homogeneous equations. So, the most faithful method is to find particulars of, to find a particular solution is a method of variation of parameters that works for any right hand side. Okay, let us do some problem with one more problem. So, we have done only one problem. I think we have done 2 problems on to find a particular solution by the method of variation of parameters. Okay, let us take one simpler one and let us solve it. Okay, solve by method of variation of parameters. Solve the equation. Solve the differential equation. Y double dash plus 4y dash plus 5y equal to sin x. Okay. So, x belongs to full R because there is no issue with any coefficient of, so nowhere, all the functions, all the coefficients are well defined for every x. So, let us what is the solution? So, this is a non-homogeneous equation. So, the actual solution is general solution is yx as yh of x, that is a homogeneous solution, plus particular solution. What is the yh? Yh of x is simply that satisfies yh, I write this y double dash plus 4y dash plus 5y equal to 0. So, yh satisfying this equation. Okay. So, if you look for yh is e power lambda x solution, because this is the equation with constant coefficients, then you get lambda square plus 4 lambda plus 5 equal to 0, for which you have lambda square plus 4 lambda plus 5 equal to 0. Okay. Can you write like this? So, what are the roots? Roots are minus b plus or minus square root of b square minus 4ac 20 divided by 2. So, minus 2 plus or minus, you have 2 4I, that is 4I under root that is simply I. So, plus or minus 2 plus or minus I, these are the roots. So, what is your homogeneous solution? That means C1 e power minus 2 plus I x plus C2 e power minus 2 minus I x, or I can write in a different form, C1 e power minus 2 x is anyway common in both terms, C1 cos x plus C2 sin x. So, this is your homogeneous solution, general solution of the homogeneous equation. So, you want a particular solution yp. How do you calculate this yp? To get this yp, I look for this C1 I vary as a function of x e power minus 2x cos x plus C2 of x e power minus 2x sin x. Okay. Then C1 C2 will satisfy, we have seen already. So, you just remember these forms. So, this system C1 C2 equal to 0 and right hand side is f is sin x, right hand side of the given equation. So, that is your f, and here what you have is, if you actually go back and see what form you have to solve this particular solution, what did you get? So, what you get is y1 y2 and y1 dash y2 dash. So, this is the form you have. Okay. So, just write C1 dash, these are C1 dashes. Okay. Y1 is, this is your y1, this is your y2. So, you can write e power minus 2x cos x, e power minus 2x sin x. And then what is y1 dash? This is your y1, this is your y2. Okay. Y1 dash is minus 2 e power minus 2x cos x plus minus e power minus 2x sin x, and here minus 2 e power minus 2x sin x plus e power minus 2x sin x derivative is cos x. So, this is what you have. This is the system where C1 and C2 satisfy this system. So, for this you can actually calculate what is C1 dash and C2 dash. C1 dash of x is simply e power minus 2x sin square x. What is C2 dash of x? No. So, you can invert this system directly and write. So, what is the inversion of this? So, 1 divided by what is the determinant of this matrix? So, you can do the determinant of the matrix, you get e power minus 4x cos square x minus e power minus 4x into 2 cos x sin x minus e power minus 4x, and then sin x into minus minus plus, you have a 2 cos x plus sin x. So, this is what you have. So, sin square will become minus e power minus 4x, this term and this term goes, and this is simply 2 cos x sin x, and this is minus minus goes. So, you simply have e power minus 4x. Okay. 1 by determinant of this, and then you simply take the determinant. So, minus 2 e power minus 2x sin x plus e power minus 2x cos x and e power minus 2x cos x and minus e power minus 2x sin x minus minus plus. So, it is going to be 2 e power minus 2x cos x plus e power minus 2x sin x. This is the inverse of this matrix into 0 sin x. So, this what you have is left with is e power 4x, and now if you now multiply, what you have is this vector is, what is this vector now? This is simply minus e power minus 2x sin square x, okay. And here simply e power minus 4x into e power minus 2x sin x cos x. So, that is what is your C1 dash C2 dash. So, this will give me, this is actually equal to minus e power 2x sin square x, and this is actually e power 2x 1 by 2 sin 2x. I can write like this, and then you can actually have you can integrate. So, this is what is your C1 dash. So, this gives me C1 of x is simply minus integral e power 2x sin square x dx, okay, and C2x is simply integral e power 2x sin 2x 1 by 2, okay. So, that these are your C1 C2 if you can integrate as an indefinite integral. Earlier we have used we integrate from x naught to x. If you do that, you can take x as inside the integrand as a dummy variable and you can actually integrate. So, this you can integrate if you know, okay. So, this I leave it as an exercise. So, this is what I hear. So, it will take, you know how to evaluate these integrals, okay. So, I will not be doing. So, if sometimes, so this example shows if you use, though even though the equation looks simpler, the method of variation of parameters of finding this C1 and C2 and then integrating, it will take a long time, okay. But if you apply the annihilation method, for example, because this is a simpler function, okay, sin x, let us see what happens here. Sin x you can annihilate with d plus d square plus 1, right, of sin x is 0, d square minus 1, right, d square minus 1 or plus 1, d square plus 1. D square plus 1 is lambda square plus 1 equal to 0 you get. So, lambda equal to plus or minus I, okay. So, if this is lambda is plus or minus I, what are the solutions? Simply sin x and cos x, or e power ix and e power minus ix. Combination also, they are two linearly independent, e power ix and e power minus ix, and also sin x and cosines, sum and difference are also linearly independent. So, you can get these are the two. So, sin x is actually satisfying this equation. So, annihilation operator is d square plus 1. So, you have d square plus 1, you operate both sides to the equation, that is d square plus 5d plus 4 or 4d plus 5, y equal to 0. So, I annihilated, this is why annihilation auxiliary equation, okay, the helping equation. So, I annihilated the right hand side and make it that equation. So, 4y dash plus, so that is what you have. So, what is its solution? Solution of this is equal to, this is the higher order equation whose solution you can easily see. So, what are the solutions here? We know our solution C1 e power minus 2x cos x plus C2 e power minus 2x sin x. These are the two linearly independent solutions that we have already seen here, okay, y1 and y2. And what happens to this? This part will give me C3 sin x plus C4 are the solutions, right. So, these are the four linearly independent solutions for this equation, for this fourth order differential equation, annihilated equation, okay. In this we remove this homogeneous solution. So, in this form you look for as a particular solution, C3 sin x plus C4 cos x. You calculate its derivatives and put it into the equation. So, yp dash is C3 cos x minus C4 sin x. Yp double dash is simply C3 minus C3 sin x minus C4 cos x. Now, you substitute into the equation. So, you will get minus C3 sin x minus C4 cos x plus 4 times y dash, that is yp dash, that is 4 C3 cos x minus 4 C4 sin x plus 5y, 5 C3 sin x plus 5 C4 cos x. What is the right hand side is given as sin x. So, you see the equation left hand side is fully coefficient of sin x or cosine x. So, equate sin and cosine are linearly independent, you know that. So, because they are linearly independent, you can equate the both sides coefficients sin x, right, this is sin x. So, sin x coefficient, if you make it equal, so you get minus C3 minus 4 C4 plus 5 C3. So, that is going to be plus 4 C3 equal to 1, and what is the cos coefficient? It's minus C4 plus 5 C4. So, that is going to be 4 C4 and here 4 C3 plus 4 C4 equal to 0. So, this will give me C3 equal to minus C4. Once C3 equal to minus C4, what is my C4? So, substitute here. So, you will have minus 4 C4. So, it is going to be minus 8 C4 equal to 1, that will give me C4 equal to 1 by 8 minus, and C3 is simply 1 by 8, that is all. So, you have got the solution, very simple. The simple calculation method of undetermined coefficient gives you in a simpler way solution, you can easily find in a easier way. So, ypx is simply C3, go and substitute sin x by 8, 1 by 8 times sin x minus cos x, this is your solution. So, yp, so that implies the general solution which you already know, C1 e power minus 2x cos x or sin x as your whichever way you can write, okay, cos x plus C2 e power minus 2x sin x plus this particular solution. This is the general solution of the homogeneous equation plus particular solution sin x minus cos x. Okay. So, this is your general solution of the given equation. Okay. So, this is how you can see sometimes method of variation of parameters will give you easier way to find the particular solution. Sometimes if the equation is constant coefficients, also right hand side are having elementary functions, you can easily work out with method of undetermined coefficients. Okay. So, with this now you know the method, you have certain methods, second order linear homogeneous equations or in second order linear non-homogeneous equations, you can solve, you can actually find the general solution of the given equation. And sometimes you may be asked to find a solution of instead of solving the equation, you may be asked to find the solution of the linear second order equation with non-homogeneous term with an initial values. Okay. In that case, the arbitrary constants in your general solution, you can those things you can fix it from the given initial conditions. Okay. For example, let us take this equation, the same equation here. If you are asked to solve the equation with y at 0 equal to 0, y dash at 0 equal to 1. Okay. If you are given equation like this, if your problem is this, that then these two conditions will fix the final general solution, the coefficients in the general solution. This will fix C1 and C2. So, let us make it y0 0 will give me y, put x equal to 0. So, you have C1, C2 is 0. So, plus 1 by 8, so minus 8. So, cos 0 is 1. So, that is equal to 0. So, this will give me C1 is 1 by 8. Okay. And what happens, y dash of 0 is 1, this will fix it what is the y dash? You have to find the y dash of x. So, that will give me y dash of x. You need to calculate y dash of x, that is minus 2 c1 e power minus 2x cos x plus c1 e power minus 2x sin x with minus 2 c2 e power minus 2x sin x plus c2 e power minus 2x cos x, and here 1 by 8 cos x plus sin x, that is the derivative. So, now we put y dash of 0, okay. Now we put y dash of 0 equal to 1, that if we put it y dash of this, y dash of x is this, only cos x terms will contribute. So, we will have 2 my c1 e power that is 1 and plus c2 plus 1 by 8 equal to 1. You already know what is c1, c1 is 1 by 8. So, you have 4. So, c2 is equal to 1 plus 1 by 8. So, 9 by 8. So, this gives me, so the actual unique solution, the solution is the required solution, required unique solution. You are fixing C1 and C2. That means you are given initial values, initial value problem, because for the linear equation is unique. Okay. So, unique solution is y of x equal to, you fix your C1 and C2. C1 is 1 by 8, 1 by 8, 1 by 8 e power minus 2x cos x, and this is 9. So, plus 9 sin x. Okay. So, this is what together first two terms plus 1 by 8 sin x minus cos x. So, you can 1 by 8 take it out. So, this is the solution, unique solution of the given equation with the initial conditions. Okay. So, you can sometimes you can be asked to find the solution of the given equation, linear equation with the initial conditions. So, these initial conditions will help you to fix the constants in the general solution. So, that makes it the solution unique. Okay. So, you will be able to fix these constants uniquely. Why you are able to do it? Because the equation from the theorem without proof, we have given without proof, we have given the theorem without proof that any linear equation with any linear equation will have a unique solution when once you provide initial conditions. Problem of a initial linear equation will have a unique solution. Okay. So, from that you can conclude that how to find the general solution, or in fact to find a solution of initial value problems for certain second order linear equations. Okay. So, we will see what we are still not knowing is we still do not know how to find solution of a linear equation if the coefficients are not constants. If you have a linear equation with variable coefficients and you still do not know how to find one solution, then you are in trouble. You do not know other solution, you do not know how to find two linearly independent solutions, even though you know that the equation will have only two linearly independent solutions, but you do not know how to find them. Okay. If your equations with variable coefficients, we can actually find by power series solutions. Okay. We will see that. I will give ample introduction on power series, some calculus part, and I will introduce in my next video, so that you can find the solutions of two linearly independent solutions of these homogeneous equations. Okay. We will again look at the homogeneous equation with variable coefficients. Okay. So, those equations for which you cannot find y1 and y2. Okay. So, we will see that in the next video.